Hello everyone, welcome to Ladboy coding. Today we are going to solve problem 380, insert, delete, and get random in constant time. And we can see this is a really commonly asked interview question. The problem is very straightforward. We need to design a data structure that supports insertion, removal, and get random in a constant time. So think about it. What kind of data structure would support insertion in constant time? We can use an array, right? We just need to put it in the end of the array, or we can use a hash map. What kind of data structure support constant removal? It's also O of a 1 for hash map. For the array, we need to be careful because if we remove the last element in the array is constant, but if we remove the middle element in the array, the rest of the element need to shift to the correct index. So the removal in array is not always constant. How about get random? Can we implement a get random function for hashmap in constant time? We can't because to implement get random, we need to have an indexed data structure, which is array. So from this analysis, if we just need to support insertion and removal, we can use a hash map. But if we need to support insertion and get random, we need to use an array, right? So what kind of data structure should we use? We will use an array and the hash map together. In this problem, I will code it, and then in the meantime, we will do the visualization. So let's get started. So first, we need to initialize the array and the hash map here. So to insert an element, what we need to do, we just put it into the array, right? So here we just put 1. For example, if we insert 1, and the index of 1 is a 0, right? So then what do we do in the hash map? We need to map the current value to the index. One map to 0. How do we implement this? The index is the length of the original array, and we map the value to the index. So we create this structure. So we need to return true if the set do not already contain the element. So if var is not in the hash map, then we can insert and return true. Otherwise, we just return false. How does the removal work? Let's insert more element into our data structure first. So let's insert 2. The index is 1, and we map from 2 to 1. And then we insert 5. The index is 2, and we map from 5 to 2. How do we do the insertion? So how do we do the removal? So first, we need to get the index of the current element. So for example, if we want to remove 2 from the hash map, we know the index of 2 is 1. And then we need to get the last element in the array. So the last element is 5. Then what do? We use the last element to replace the current element that we need to remove. So index is last element. So the index is 1 and the last element is 5. We cover the 2 to 5. And then what do? We update the last element index in our hash map. So now the last element index become 1, right? Then we need to remove the old element. We remove 2. There's no 2 in our hash map. And last but not least, we also need to remove 5 from the array. This is our constant operation. If we follow the pointer in our data structure 1 by 1, then it's become very clear. And notice we need to return true if the element is in the data structure. So if var is in self.hashmap, we do this and return true. Otherwise, we return false. How to implement GetRandom? There's a function from Python called choice, and it will just give us a random element from the array. So this is our code. Let's run it. Yes, it's correct. And let's submit our code. Yes, it's correct. Well, no need to analyze our time-space complexity because it's all constant, right? But I do want to highlight one more thing. You may be curious, what is this choice? What is the logic and algorithm behind it? So let's take a very quick glance of Python source code. So from random, import choice. Well, random is a model, and we can see the source code of the random here. And let's search choice. This is the function that implements choice. Well, the sequence is just an array, and we pick a random number times the length to give us a random element from the array, right? So what is this self-random function? Let's take a look. This is the random function. It uses Wishman-Hill random algorithm, and we do some math here. So these are all a math. You can learn more about the detail by Googling Wishman random algorithm. So what is seed? The seed is just a few numbers to initialize the sequence of the random number. So we usually set it by the current time. So these are a little bit implementation detail of the random function. Okay, thank you for watching. If my solution helped you, please feel free to subscribe.